Welcome to Unit 11, Part 2. Today we're going to do a memory placement exercise. These are jobs. These jobs could represent segments or actual processes, and we're going to place them in memory, and we're going to follow these rules where we're going to do coalescing wholes if we have two adjacent wholes, storage compaction, which is at time 20, and we're going to, which means move all of the wholes into one end of memory. And we're just going to see how long it takes to do these 7 jobs. And in this, you'll get to see what external fragmentation means. And I can discuss a little bit about first fit, worst fit, and best fit. This is a very small example, but you'll get an idea of the amount of management involved in memory management in just looking at this small example. So these are small jobs, and we only have 1 meg memory. And we're just going to switch, and if you notice, like job 1 is 500 kilobytes and it takes 3 time units, so we're going to only allow each job to do 1 time unit of work. So let's get started. So on the bottom I have a timing diagram, and here is my 1 megabyte of memory, and you'll notice that job 1 is 500 kilobytes, so it's half of the size of my memory. So it's going to be loaded into memory, and it's going to get to do 1 time unit of work. And then we'll load job 2, which is 250 kilobytes, so it's going to fit in the remaining 500 kilobytes. And job 2 will do 1 unit of work. And then we'll do job 3, which is 200 kilobytes. And now our 1 megabyte of memory is full with job 1, job 2, and job 3, and we will have a hole in memory of size 50 and we cannot fit any of our other jobs in there at this time. So what we'll have to do is we'll have to cycle through these jobs until we get a hole, and then at that time we can place another job in memory. So let's cycle through job 1, followed by job 2, followed by job 3, followed by job 1, and now job 1 has completed, and now we will have a hole in memory size 500. Now we don't care at this point. The exercise is not about each job and how long it takes to do each job. The exercise is about how long it takes to complete all these 7 jobs, and just to illustrate what external fragmentation is. And if we had more memory, we could do a comparison between whether first fit was better, worst fit was better, or best fit was better. But because we only have a small amount of memory, we're just analyzing with first fit because we aren't going to have a lot of space. But you could have a larger exercise that takes more time, and you could analyze the different techniques. So now we have our hole, which is size 500, and we can load in job 4, and we will have a space left of 150. And when a job gets loaded in, it goes first. So job 4 is going to go, followed by job 5. There's space for job 5. And now we have a hole of size 90. The total size of our hole external fragmentation is 140. So if we were to have a job that was like say size 100, we would have external fragmentation because we would have enough memory available, but it would not be in a contiguous area, and we could not accommodate that request. And that's going to happen shortly. So now let's cycle through our jobs until we get another hole. We have job 2, job 3, job 4, job 5, and now job 2 is finished, and now we have a hole in memory. So this hole is the size that job 2 was, which is 250. And then we will perform what's called coalescing holes and make that all into one hole size 340. And now we will be able to put job 6 in, as you can see here. And job 6 will go, followed by job 3. And so now we will just continue where we off. I ran out of space. We're on a new slide. This is the same. We just the current time is 17. We just finished job 3. And none of them have completed yet that are in there. We still cannot fit job 7 because we do not have enough space for job 7. And so now we will let job 4 go. Job 4 has finished. And now we have a hole of size 350 and a hole size 40 and a hole size 50. But what happened is Job 7 is size 400 and it will not fit in any of these holes. Now say for example, job 7 was size 35, then it could go into any of the holes and you could try to do a best fit, worst fit, or first fit strategy. But in this case, we are going to show that we have external fragmentation because job 7 is size 400. And if you took all of these holes and moved them, which then we will do at time 20, which is called storage compaction, then we would be able to accommodate job 7. But at this time, at time 18, we do have external fragmentation, which means that we have a job, we have enough memory available, but it is not contiguous. So now we will continue to cycle through until we can either do storage compaction or we clear the memory. So job 5 will go, followed by job 6. And now the current time is 20. So now from time 20 to 24, we will perform storage compaction, which means we will move all of the jobs to one area and we will combine the holes that are there into one large hole. And now we can put job 7 in. So job 7 is the new one to be loaded in, so job 7 will go first, followed by job 3, which is now done, followed by job 5, followed by job 6. And now since job 6 and job 3 are adjacent, we will perform coalescing holes. Then we will run job 7, and job 7 is done. And job 7 is adjacent to the hole we just created. So we will once again perform coalescing holes. And then we will have job 5. And now we can see that it took 32 time units to complete these jobs. And we were able to demonstrate what external fragmentation is and talk a little bit about the concept of best fit, first fit, and worst fit, although we didn't have a large enough memory space to really demonstrate that. So thank you very much and have a great day, and you'll hear from me in the next video.